Okay, welcome to AP Physics 1, Video 4 on forces. We're now going to be looking at even more situations. Today we're looking at forces applied in y directions and how we handle that, and some more accelerating systems. Okay, we have a hutch being pulled at an angle downwards, 20 degrees to the horizontal, and our job is to figure out the acceleration of this. Okay, well, we have that applied force there. We need to break that up into its vector components. This is a horizontal force, and this is a vertical force. And of course, we're going to have a friction force going against. And we can't forget about gravity and normal. Okay, so let's label all of those right now. This one is going to be force normal. Downwards is force gravity. And to the left here is going to be force friction. This one works very similar to our horizontal pull, except we have to remember to break our force applied, which is our hypotenuse, into force applied x direction and force applied in the y direction. Please remember that force normal, in this case, is going to equal force gravity plus or minus force applied y. And of course, in class, we always have to remember which one it is. So if we're pushing down on the object, we're actually allowing the object to think like it feels like it weighs more on the ground. Remember, normal is a reaction force, okay, to whatever the surface is feeling. So if you're pushing down on the object, in this case, we're actually going to add. So we're going to do force normal equals force gravity plus force applied y. If I was pulling up on the object, then the object will feel like it weighs less because force applied y is holding up a little bit. I would then subtract. So normal is probably opposite than what you think it should be. If the applied force is angled downwards, you're going to add force applied y. If it's angled upwards, you're going to subtract it. So these two forces are not equal to each other. But our net force is going to then be today, so force net, and notice how we always look at the x direction. That's going to equal force applied x, and we're going to subtract force friction from it. Okay, but you need to calculate force normal first by doing force gravity plus force applied y. And of course, plug in MA for force net, and then your force applied x value and your friction. Okay, well, how do we get these? Force applied x is then going to be force applied, and our angle is right here, so that is the adjacent side, so we're going to do cosine of theta for that one. And force applied y is going to be force applied, and we're the opposite side this time, so that'll be times sine of theta. So we're back to usual, I suppose, in terms of force applied y is sine and force applied x is cosine. So that's how you handle what I call an angle pull, something that's being pulled along a horizontal, but the applied force is at an angle to that horizontal. Okay, now back to accelerating systems here. What about a pulley? Now there's a variety of ways we can do pulley systems. I've chosen an incline as our example today. Okay, so let's take a look at what forces are involved with this. This is a systems of equations. We will have a force gravity downwards on this word and a force tension going upwards like this. So let's label those. Now we have to remember to choose a direction that's positive. Let's say this way, the direction that the object is going to be accelerating this way around. So let's call that one positive. So this is going to be force tension, and downwards is going to be force gravity. Okay, now we are not paying attention to the mass of the pulley right now, and the string is very light. So that's all we have to worry about. We don't have to worry about moment of inertia for that. So the systems of equation for this one then is going to be force net is going to equal force gravity minus force tension. So we'll put values in for that. So MA is going to equal mg minus force tension. Okay, now for this object, depends on what we're given. And let's go to the worst condition here. So we have a force tension going upwards, and we have a force friction and force gravity X going against. So we're going to call this one force tension. Then we have force friction going in this direction, and force gravity X also going in this direction. Now, I'm not going to redefine these up. You can see one of the first couple of videos for Cram session to get these values here. Okay, but our force net equation for this will then be force tension minus force friction minus force gravity X. Okay, and this direction's positive, that way this one's positive. So we would then have A, and let's call this one M prime A, put a little prime in that because that's a different mass, equals force tension minus the friction force minus force gravity X. Now, this will involve a systems of equation. Why? Because I've got two equations, and let me underline both of those equations so that you can see them. And I'll put that in a different color. So this equation here is one equation, and this is the other equation here. And you can use addition method here. You will know the value for this. You will know the value for this. Okay, and let me make sure I put force gravity X on this one, because it's force gravity X. So you will know these two values. You know the mass. The only thing you don't know is acceleration and tension, and that's true in this one. You know acceleration and tension. So it is a systems of equations, and I like to use the addition method, because if I add this equation to this equation over here, we have a negative force tension and a positive force tension. Those will cross off, and that would allow you then to solve for acceleration. Then you can plug back in to find force tension. So those are the typical things we want: force tension and acceleration. Okay, and that's how you handle those systems of equations. We'll have one more example to follow in our next video.